Hello, welcome to my channel. In this video, I'm going to be discussing or talking about fractions. So first of all, what are fractions? I know when most people hear the word fraction, they usually think of, let's say, stuff like 1 over 2 or 8 over, so this is 8 over 9 or 100 over 3, for instance. But I want you to know that fractions are more than these. They are numerous. In fact, they are unlimited. Let me just use that word. And is this type of fraction is also the kind I'm going to be discussing in this video. Now you can check my other video on fraction, which I posted previously, but it doesn't cover what I'm about to teach you now, so I want you to take note of this. They are both important lessons. The link to the other video will be in the description box below. So for this particular topic, I said when you hear the word fraction, most people will consider what I have here. But aside from this, other examples of fractions include 2, 3, 4, 5, 6, and all the way to infinity. All these numbers right here are all fractions, but they are somehow another type of improper fraction. When that all of them are divided by 1, meaning 1 is a denominator for all of these numbers. And again, these type of numbers are called integers. Well, I'm not going to be discussing this in this video. If you want to learn more, I suggest that you check my other video on fraction. Well, in this video, I'm going to be teaching you more of the practical aspects of fraction, which involves a little more calculations. But before we go into the calculation parts, let's consider this first. Let's consider this shape. This is a square, and I'm going to divide it into 4 parts. Now, out of these 4 parts, if for instance I shade three parts, please forgive me if my square is a little crooked or bent. So now I've shaded 3 out of the 4 parts of this square. Now if you were asked what is the fraction of the shaded part of the square, well, what's the solution to that particular problem is easy. To determine the fraction of the shaded part, you just have to count the number of parts that are shaded, which is 1, 2, 3, and divided by the total number of parts which the square is divided into, which is 4. Now, assuming the square was divided into 8, 10 parts, it will be the fraction will also be the number of shaded parts divided by the total number of parts that are split. So for this particular square, the fraction of the shaded part is 3 over 4. Since 3 parts are shaded and 4 parts make up the entire square. So, and if we are also asked what is the fraction of the unshaded portion, the unshaded portion is just only one part, which I just shaded black. So the fraction of the unshaded portion will be 1 over 4. And note, when you add the fraction of the shaded parts to the fraction of the unshaded parts, you are always going to get 1, which their sum is equal to 1. So if I should add these 2 fractions over here, it will give me 1. That is just the basic idea of this illustration right here. Now let's take another illustrative example. Let's say we have the calendar. And we're going to divide it into 4 parts. So we can have all the months of the year inside this calendar. So let's take the following month. Here's January, February, March, April, May, June, July, August, September, October, November, and December. Please forgive me if my handwriting is a little bit crooked or bent. So let's consider this calendar, for example. If we were asked how many or what is the fraction of 8 months out of all the months of the calendar, well, we just have to count 8 months out of all the months. There's January, February, March, April, May, June, July, August, which is 8. Since they didn't tell us what 8 months to choose, we can choose any 8. And even if they did tell us what 8 months to choose, the answer would still be the same, so no need to bother about that. So the fraction of 8 months of the calendar would be the number of months required, which is 8, over the total number of months, which is 12. So this is the fraction of 8 months of the calendar. And if we decide to break this fraction down further, 8 over 12 can also be seen as 2/3. If we break this down, we are going to get this fraction right here. So what this means is that 2/3 is the same as 8 over 12. What that also means is that when we have completed 8 months in the entire year, meaning we have gotten through 2/3 of the year. Let me just rephrase that statement in case you didn't understand. When we have gotten through 8 months of the entire year, which consists of 12 months, it means that we have gotten past 2/3 of the whole year. It's like saying the year is spread into 3 parts. 1, 2, 3. And each part has 4 months. 3, 4. 1, 2, 3, 4. We have gotten through 4 months in each part, which will make it 8 months in total, remaining 1. And if I was to illustrate this as a fraction, meaning I have 2, which is the part we have gotten through, divided by the total number, which is 3. So you can see how this is related to what I have here. So now, what is the fraction for 10 months? Well, the fraction for 10 months will be simply 10 over 12. And if I break this further, I'll have 5 over 6. Meaning, if the year were to be divided into 6 parts, if we completed 10 months out of 12 months, meaning we have completed the year 5/6, the 5/6 part of the year. This is just what this means. So now what if we are asked to write the fraction of, let's say, 2 months, for instance? Well, the fraction for 2 months will be 2/12, and if we break this down, we'll have 1/6, meaning completing 2 months out of the entire year will be 1/6 part of the year. Now please, I want you to take note of this. You know, earlier I said when you add the parts, to add the part that is required of you to find the fraction of with the other part that is left out, I said that the answer would be equal to 1. That is what I said earlier. But in this case, adding 5/6 to 1/2 is going to give you 1. Yes. Why is it going to give you 1? Because out of 10 months which we picked, 2 months are left out. So if we picked everything here, let's say we left out November and December, meaning 2 months will be left out. And if we add the fraction of the one we picked, which is 10, and the one we did not, well, we picked 2, but the one that was left out, which is 2, is going to give us 1. But assuming it was, let's say, 10/12 plus, let's say we picked 3 months, 3/12. If we add these two fractions, we'll have 13/12. Which is not equal to 1. It's, well, you can say it's approximately 1, but it's not equal to 1 because it is 1 month more than the number of months in a year, so it will not be equal to 1. Well, in summary, what I'm trying to say is, when you choose a part of the entire calendar, let's say you picked 4 months, if you add the fraction of 4 months to the remaining 8 months, it's going to be equal to 1. But if you pick 4 months, for instance, and then you decide to add 9 months to it, note that your answer is not going to give you 1. This looks like a big shoe. Let me just erase it first. Now let's try an example that doesn't involve maybe a diagram. Peter was given 18 books. He read 4 and gave the rest away. He read 4 and gave away the rest. A. What is the fraction of the books he read? B. What is the fraction of the books he gave away? C. What is the sum of both fractions? Here you can try to work on this problem by yourself. Well, feel free to pause and try it by yourself, but now I'm going to start solving in case you don't know what to do. Peter was given 18 books. He read 4 and gave the rest away. Gave away the rest. I don't know why he would do that, but I guess different people have different ways of handling books. So Peter read 4 books, and you're asking what is the fraction of the books he read. Since he read 4, our fraction for the A part of the question would be 4 over 18. And if we break this down, we'll have 2 over 9. So this is the fraction of the books you read. Note, you can leave your answer like this anytime, but it will be better if you simplify your answer by reducing it to the lowest term. So let's move on to the B part of the question. They asked, what is the fraction of the books he gave away? In the question, we were not given the fraction of the books he gave away, but they gave us the parts that he read, which is enough to find the ones that he gave away. So the ones he gave away would be 18 minus the one he read, which was 4. 18 minus 4 is 14. So meaning he gave away 14 books. So therefore, the fraction of the books he gave away would be 14 over 18. And if we simplify this further, we have 7 over 9. And see, what is the sum of both fractions? Well, we are going to add both of our answers together. So we'll have 2 over 9 plus 7 over 9. And if I add this together, it will be, we'll have 2 plus 7, and this will be 9 over 9, which is equal to 1. And this also proves what I said earlier about adding the part that was required and the part that was left out. The sum is also always going to be equal to 1. And also, if you decide to add these two, it will also give you 1. You can try to add that by yourself on your own time. Now I want you to know that fraction is an important tool in math. It's also kind of confusing, but it's very fun to work with, and it's a way of being more specific about certain numbers. And note that fraction is a very useful tool when you are solving problems on probability. Yeah, fraction is a useful topic in that aspect. Well, now I want to just mention that I'm kind of sorry for delaying this post. Well, it took me a long time to prepare this post. I know that sounds kind of unreal. Well, I had some other things, important things that I had to do, so I had to pause posting videos on YouTube for a while. Well, I'm sorry for that, and please, I like to encourage you to like and subscribe to this channel so I can post more videos that you can learn. And stay tuned to watch my first video on physics. I'll be posting a video on one topic in physics. I want you to stay tuned so you can catch that video. Thanks for watching.